In this video, I'm going to feature problem 53 and supplement to chapter 6. It has to do with acceptance sampling and average outgoing quality. But before we start, I want to talk about the three levels of quality initiatives that you might have. So first, we start with acceptance sampling. Except when you do acceptance sampling, you're essentially, this is prior to you even having started a statistical process control at your company. With acceptance sampling, what you're doing is you're taking a a batch that you're going to ship to your customer, but before you ship it, you sample it and you replace bad units with good units before you ship it. You don't want that because that means rework, scrap, and lost money, low quality. And you may not be able to catch everything. So really, essentially, the next best thing that you should do is statistical process control and control charting. And of course, beyond that, then you want to go and do process capability and make sure that you are continually moving from 3 sigma to 4 sigma to 5, 6 sigma, etc. So this problem, of problem 53, features acceptance sampling. And when you do acceptance sampling, you want to essentially make sure that your average outgoing quality for the batch, it meets a minimum criteria. So average outgoing quality is essentially that least quality level that is going to be in a batch. It's the highest percentage defects, essentially, highest percent defect that you might have in a batch that you ship to your customer. So it's important to be able to manage that. Now, how do you compute average outgoing quality? There are a few parameters that go into it. One is what we call P sub D, and that's essentially the true percentage of defects in the sample that you are collecting. Then there is a P sub A, and that's the probability of accepting the lot for a given sample size that has a certain quantity of defects in it. Then you have capital N and lowercase n. Capital N is the lot size, is how big the lot is or the batch is that you need to send to the customer, and lowercase n is the size of the sample. And you divide all that by capital N. So in this problem 53, it says the percent defects from an incoming lot is 3%. So percent defect, that would be P sub D, that's 0.03. An OC curve showed the probability of acceptance to be 0.55. So that's P sub A, and that's 0.55. Given a lot size of 2,000, so that's N, 2,000, and a sample size of 100, so 2,000 minus 100, and then we divide that by 2,000. It says determine the average outgoing quality in percent defect. So if you go through that, you get 0.016. Now compare that. Average outgoing quality is 0.016. We started out with the percent defects from the incoming lot being 3%. And after doing acceptance sampling, we're able to reduce it down to 0.016. So it's almost half the size the amount of defect, the percent defect that it was before sampling, before acceptance sampling. So, but keep in mind that when we do acceptance sampling, that requires or assumes that defective units are replaced if found in the sampling process. So if you find a defective unit within the sample, then you replace it with a good one before you send it to your customer. And this is, of course, again, after the fact action that you have taken, and all the rework, all the defects have already been produced, and you're spending time to find those defects, to replace them, to rework them, and so that adds to the cost of quality. What you want to do is move away from acceptance sampling to SPC, so that you're continually monitoring the process, so that you're catching a process that's not performing within specifications and within control, so that you can adjust it right then and there before you produce a whole bunch of units and then you do acceptance sampling to find out that so many of them are defective. Okay, thank you.